Okay, these are the notes for transformations. You should already done the packet. So this is just a Cliff Notes, small version, quick version of what you should have learned from the packet. So make a paper like this. Okay, transformations. First off, you should know that they have a pre-image. And that's your original image. Then we have the image, and that's the transformed image. Then we have the word prime. It identifies an image. So it's written like this, A with a little apostrophe. That apostrophe is the prime. It lets you know that I already did something to it. I already transformed it, I reflected it, rotated it, whatever I did. Okay. Okay, then reflections. When we reflect over the y-axis, the X sign changes. When we reflect over the x-axis, the Y sign changed. We reflect over Y equals X. X and Y switch places. When we reflect over Y equals negative X, X and Y switch places. And the sign changes. Okay, translations. We have mapping notation. Was written as XY, then X plus 3, Y minus 2. The X plus 3 means I'm going to the right 3, and the Y minus 2 means I'm going down 2. Vector notation. It's written like that. This is saying the exact same thing as this. It's going to use brackets, not parentheses. It's still saying going right 3, down 2. Rotations. If you're going clockwise, you're going to go to the right. Counterclockwise, to the left. If they don't tell you which direction to go, you automatically do counter. On a graph, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. 90 degrees is one turn. 180 degrees is 2 turns. 270 is 3 turns. and 360 is 4 terms. If it's in this quadrant, you should know it's 2 positive numbers. If it's in this one, you should have a negative and then a positive. This one, it should have 2 negatives. This one should have a positive, then a negative. So that's kind of eliminates some of your answer choices sometimes. So like if I know my quadrant started here and you tell me 270, that's going to move 1, 2, 3. So I know my answer is going to be a positive number and a negative number. Let's go to dilations. Scale factor describes if the image is getting smaller or bigger. If it is smaller than 1, it's getting smaller. If it's greater than 1, it's getting bigger. If it's equal to 1, it stays the same. Smaller can also be written as reduction, and bigger is also an enlargement. Okay. Remember on the packet, if you are finding if you're dilating the figure about a point, you have to find the slope of that point. So you can write this on your little paper too. You're going to find the rise over the run from the center of the vertex to each, for the center of dilation to each vertex, and then multiply the rise over run times the scale factor to get your points. Now, if it's the origin though, if your center of dilation is the origin, all you have to do is multiply. So like on this one, it says dilate -3, 12 by a scale factor of 2 about the origin. So I took -3, 12, and all I did was multiply by 2 because that was my scale factor. So that gave me -6 and 24, and that would have been my answer. Okay, so when it's about the origin, you just multiply. When it's not about the origin, you need to find your rise over run, and then multiply your rise over run times your scale factor.